All right, so let's keep looking at some script stuff. So we currently have our game object. We have a cube in here, and I also have this empty game object. I'm going to actually get rid of that for right now just to keep things simple. So I have this cube. I also have a script. And actually, I'm going to go ahead and I'm going to rename this script. I'm going to name it movement. Okay, because we're going to use this here in a few minutes. We're going to follow we're going to follow this little tutorial thing, but we're not going to watch the videos or anything. I'm just going to grab code and I'll explain what it's doing just to save time for the code. So go ahead and open this guy back up. All right, so now just to explain a couple of things that are in here. When you first create the script, what you get is you get a start function. So this is the initialization. This is the constructor. So this guy gets called one time when this script first starts up. Okay? Now, if you attach this script to multiple game objects, you can have one script. You write the script once, then you attach it to 5 different game objects. This function will get called one time per game object. All right. So, for example, you might create a script for teaching, something to just kind of walk around. All right. So, maybe in our world right now it's a cube that walks around. Okay, it's the cube animal. And then you might want to put 10 or 15 of those around your scene. Well, you want all of them to act the same. So for each one of them, you throw that walk script on it. So you only have to write the script once, and you just say, all of you guys, you follow this script. Okay? Now, a game object can have more than one script associated with it. All right, so those scripts would all try to do stuff at the same time. So you need to make sure the scripts aren't conflicting with each other. Like one script doesn't say move left while the other one says move right. that kind of stuff, and you would have problems. All right, now some of these functions that are built in are pretty important. So I'm going to show you a couple of them here. So one's called update. This other one is called fixed update. And then we have another one called late update. All right, so let's talk about each of these. So update, this guy gets called, so this function, whatever you have in this function right here, will get called once per frame for the object that this guy's attached to. Now, the issue here is what's a frame? As opposed to fixed update, gets called once per fixed amount of time. I'm not exactly sure how much time it is, but some small amount of time. Maybe it's once every 1/3 of a second or something like that. Do you happen to know?
I read an article earlier this summer that said something about it calls fixed update like every 3 frames when a physics action is occurring.
Okay. Fixed update though is it's bound to time, not frames. So let's just go with my guesstimate that it happens about 3 times per second. Just throwing that out there. Okay. So it's a fixed amount of time because it's important. There's an important difference between these two. This update method, because it gets called once per frame, that guy will get called a different number of times depending on how good your graphics card is. Okay, so if you're playing a game, the game you wrote on a crappy graphics card, you might get, let's say you're getting 20 frames a second. And you're playing that same game on a much better graphics card and you're getting 60 frames a second. Well, the difference here is this script will call this function 20 times on this guy and 60 times on this guy. So if the logic you have in there is reliant on how often it gets called, you might not want it to be bound to frames. Okay? Now, having said that, you definitely want it to be bound by frames for like movement and things like that, because I mean, that's going to be that's the lowest common, or that's the fastest it's going to be able to react to things that are happening on the screen, 1 frame at a time. Okay, so if a user says turn left, you want it to get that information the next time, the next frame that pops up, so your guy starts turning left. Whether you're going 20 frames a second or you're going 60 frames a second, it doesn't matter. You want it to get that information as soon as possible. Okay? So just understand the difference between update and fixed update is update function gets called very, very, very often. And it gets called more often on a faster graphics card, on a better graphics card. So you will put things on there that are based on performance, not based on time. Fixed update will have equivalent performance across all graphics cards. So you can have that crappy graphics card, you can have that better graphics card, but fixed update will get called the same at the same pace because it's based on an amount of time. That makes sense? So you wouldn't want to put inside a fixed update things that are based on performance. You'd want to put inside a fixed update maybe things that are kind of low priority, things that need to get checked fairly often, almost like, oversight type stuff, like, are there any enemies in the area? Because what's going to happen in that fixed update, if you're checking for enemies in the area every three times a second, it's probably often enough. If you're checking it 60 times a second, that's paranoia, right? If you can't walk across the parking lot, you just take one step, you're just looking all around. You're going to start having problems. So understand there is a performance decision that you make there. So things you put inside of update gets called every single frame. Things that you call inside a fixed update get called at a fixed amount of time. Now, the other thing you have to consider, though, is inside of update, especially on a really fast graphics card where frames are happening very often, you're going to want to be careful how much logic you put inside of update because you want to make sure it's done before the next frame. Does that make sense? I mean, you don't want to download a movie inside of update because if you're showing 60 frames a second, you got a 60th of a second to do whatever logic's in there. Now, our computers today are pretty fast, so that might be okay. You probably can do a bunch of stuff inside of a 60th of a second. That's quite a bit of time in CPU world. But you do want to be mindful of that you can only accomplish so much in a period of time. You also want to be mindful that this update function is going to get called every frame for every object for every script. Well, every frame for every script that's attached to an object. So if you have 2 different scripts and each of those 2 scripts is attached to 20 objects, now you're going to have 40 functions get called every single frame. It's going to start adding up, right? Now, these are things that might not be a humongous deal for us since we're not doing groundbreaking, high frames per second shooter games or something like that in here. But from a theory perspective, understand that's what's going on with that function. Okay? Late update. This guy's actually related to update. Late update just happens last. It's low priority. I don't think it necessarily is guaranteed to happen last. It's just guaranteed to be low priority. So you would put stuff in here that you do want to happen every frame, but it's not of absolute critical importance. If you miss a frame or two just because it didn't quite get there, it's not the end of the world. But you still want it to happen often. Make sense? So that's what you would put in stuff in late update. Generally speaking, in terms of just if you want to keep things simple and just have kind of go-to moves, update will be for movement stuff. Fixed update will be for logic stuff. Okay, because logic stuff might take some time, so you probably want to have some wiggle room in terms of when's the next time we're going to do all this logic until the next time. There's some maybe crossover there, but that's probably a reasonable rule of thumb. Okay? So, for example, if I come into print update here, or fixed update, and I say print hello world, this is going to print out to the debug log. So you can actually do this 2 different ways. You have something called debug.log. We'll go with it. Jello. These are equivalents, except I'm printing different words out. So this is kind of the shorthand for it. Print hello world. All right, so if I come back, so what this script does right now, this movement CS script, it says every so often in terms of time, print out hello world. And my feeling is that's going to happen about 3 times per second-ish. So we'll come back here to our game. I can leave Visual Studio open. Just make sure you save the script. Notice that my cube here has that. I thought I attached the script. Oh, my game was still running. Important thing. I'll just show that to you again here real quick. So right now the game's running, right? I've hit play up here. It's blue. I'm going to forget that I had it running. I'm going to go ahead and drag the script in. This is what I did this last time. So now the movement script's in there, right? I think everything's fine. I'm going to go ahead and stop. Movement script disappears. So any changes you make while the game is running are temporary changes. Now, that's actually for testing. Because what you might do is you might have your game running and you might make real-time changes to something like, oh, well, that doesn't quite look right. Let me go ahead and manually adjust it right now while the game's running and see if it looks better. A lot of time that's going to be up here in these transforms. So getting the position or the rotation or the scale, just tweaking values till it looks just the way you want it to look. And then you'll either remember those numbers or you can hit here and do copy component. So you can grab all those values after you got them set right so that once you stop the game, you can then paste the values in. Okay, so you can do real-time editing with this, which is why nothing that you do while the game is running is saved. That make sense? So it's both a benefit and a hindrance sometimes. In this case, we forgot it was running, which will happen pretty often. Okay, so now my cube actually will have the script attached to it. So there, I've attached the script. So a couple ways you can attach the script. You can either drag it from your assets over to the inspector window when you have your game object selected. Or if you don't like the drag and drop stuff, I'm going to remove that component there. You can say add component, and you can search for it. You can actually just start typing in movement for the name of it, and it'll come up, find it, movement script. So now I've added that script there. So you can either search for it through this add component, or you can, is this kind of washed out like light? It is washed out? Okay. Because if you want the box that's right next to you, the second to top button will just dim the front lights. Is that better? All right, so what I've done, I'll delete this here. You can either just drag it in from over here, or you can hit add component. Then you can search for, you just know the name of your script, so I'll just start searching for move and add it that way. Okay, so now this cube has this movement script associated with it. And what does this movement script say to do? It says on fixed update, print hello world. And this will print it out to the console. So I'll go ahead and run this. Go to my console here, and here's hello world, hello world, hello world, hello world, over and over again. So probably looks like it is happening faster than 3 times a second, but it's happening on a consistent cadence. All right, so not real helpful, but kind of showing you that we put it in the script once and it got called over and over again automatically. Okay? Now, another thing we can do is, let's say that instead of just printing out hello world, we wanted it to print out a string that the user gave us. Okay? Or we're actually going to do something with speed here. So what I'm actually going to do is I'm going to create a public variable. We'll make this guy a float, call it speed. So that's how you define a variable in C#. So it's the type followed by the name. And when I made that public, something very important happens in Unity. So by making a variable public, what happens is, when I go, make sure you've saved the code. When I go back out here, you're going to notice something's going to pop up here. Notice I have a variable here now called speed. So by making that variable public, it exposes it to the Unity editor. So now I can come in here and I can type in a value for that. So I'll type in 15, let's say. come back in here. Now, rather than printing out hello world, let's print out speed. So it should print out 15 right now, right? So there's my 15. Now I'm going to change this to 20. Notice it's now printing out 20. I changed it in real time because the script is still running. Okay, so this is a way for me to provide inputs from the Unity editor into my scripts, if that makes sense. Okay, because in a couple minutes here, we're going to have we're actually following a tutorial called Roll a Ball, which is kind of a good first 3D tutorial. We're not going to watch the videos and stuff. I'll steal a code and I'll explain what's going on with it. But you know, what that guy does is shows you some movement stuff. But for instance, if we're going to have a ball that moves around, well, we might want to be able to adjust our speed ourselves here. Because maybe we decided, oh, 15 is a little bit too quick. And maybe while the game's still running, we tweak it and say, oh, well, 11 feels pretty good. And then when you stop it, you set it to 11 for good. So you can kind of test it while it's still running. All right. So what I'm going to do here is just to get the, pun intended, the ball rolling. I'm going to shrink some of these things down just so we have a little bit bigger window to play with. All right, I'm going to go ahead and I'm going to get rid of this cube. So what we ultimately want to have here is we want to have a ball that we can drive with the keyboard. Okay, they'll drive around, but we're going to give it some walls and stuff like that. So we're going to kind of see how building out the interfaces will kind of work. So I'm going to start off. I'm going to go ahead and click. We're going to do, we're going to create a 3D object. Now you can go a couple different routes here. What the tutorial has you actually do is use a plane. Okay, so it's going to give you something that looks like this. So big flat surface is what a plane is. All right. Now, so I'm going to rename the plane up here. I just clicked on it. I'm going to call it floor. So now it's my floor. Okay, now I'm going to right click. I'm going to create a 3D object. I'm going to create a cube. I'm sorry, a sphere. Now, notice that right now my sphere is a child of the scene. In a little bit, we're going to start playing around with what if you have game objects that are actually children of other game objects. So for example, I can actually put that sphere as a child of the floor. And if I do that, now when I move the floor, the sphere goes with it. As opposed to if the sphere was separate from the floor, when I move the floor, the sphere stays. So when you have game objects nested within other game objects, the top level parent, if you move him, everything else comes with it. And there has some other caveats other than that too. So I'm going to grab my sphere. I'm going to throw the sphere above the ground here. Now notice I have a shadow. Why do I have a shadow? Because I have a directional light above here. Now, directional lights, they have infinite distance, so I'm actually just going to drag it up here, kind of out of the way right now. Just the way, you know, nothing changed visually for us. I just don't have this extra component sitting out there. Okay, and the directional light came with my scene. We'll mess around with different lights in another example. All right, so but right now we probably want our floor and our ball maybe to look different, right? So we're going to go ahead and we're going to go out to our project. We're going to start organizing stuff a little bit here. So I'm going to go ahead, I'm going to create a folder. I'm going to call this folder scripts. And a lot of times the examples, they have you name the scripts folder with an underscore. So underscore scripts, that way it's at the very beginning of your folder. And then I'm just going to drag my movement script in there. Just doing some house cleaning, kind of organizing. This isn't, you know, nothing that you have to do. This is more of just it's a good idea, especially as your project gets bigger and bigger, that you keep it somewhat organized. I'm also going to create another folder called materials. I'll open up this materials folder. Actually, I'll do it out here, and then I'll just drag it in the materials folder. So I just have an empty folder for materials. Materials are how we give things color. All right, so I'm going to right click here. I'm going to create a new material. All right, and we're going to call this guy red. So this guy's going to be a red material. Now, over here in the inspector for my material, so I have my material selected. Here's the details associated with my material. I'm going to go ahead and click on this little color palette thing here. And we'll just pick a red color. All right. So there's my red color. And I'm going to go ahead and I'm going to drag that material into that folder, in theory. Okay. Now, we want the sphere to be red. That sound good? Okay. So I'm going to click on my sphere. I'm going to drag this material over here. Oh, hold on. I got to get rid of. No. That's weird. It won't let me delete a material. Oh, that's actually better than it used to be. So now your spheres get a default material associated with it, so you can go in and set its color. You used to have to create a separate material in order to accomplish that. So now I don't even need the separate material. So I'll delete that guy. No, it does. Let me go back and look at what the default of it ends up being. So I'm going to create a sphere. There's that initial sphere. Here's its default material. Oh, so it won't let you edit the default material. It looks like it will, but it won't actually let it. So we are going to need to make that material. They've actually just made it more confusing. So I'll create a material. Now I can choose the color of this material. I'll choose the red. I'm going to name this guy red. And I'm going to drag it out there onto the sphere. So now I have a red sphere. Okay. When I start my game, it looks like that. All right. Now, what we might want to do is we might want to have a camera be a little bit more above, for this. So let's go ahead and let's move our camera around a little bit. So I've selected my main camera. So now I'm going to move the camera around. So when I select a game object, which the camera is a game object, I have all these guys up here in the upper left. So this one right here is move the selected object. This is rotation. This is scale, change the size of it. So I'm going to do movement. So movement gives you these arrows. Scale gives you little boxes. And then rotation gives you this, and we'll mess with rotation actually probably here in a second. All right, so what I want to do is I want to have this guy probably more above the scene. I'm going to kind of bring him up here. And then maybe rotate it down a little bit, so kind of like the camera's up here and then pointing down onto the scene. So now I'm going to need to rotate it a little bit. Now notice when I move this, watch the values over here for position. So as I'm moving it, see the position values are changing? So you can change those by hand. I can decide, okay, I'm just going to put the Y position, which is up. I'm going to put that at 6 if I want. So you don't have to do the drag thing. Maybe you use the drag thing to get close. So what you'll see in a lot of video tutorials is, so let's say that I want it right around there. So that's 3.56. Maybe I'll make it 3.5. Less decimal places, you're helping yourself performance-wise just a little bit. And that might add up if you have a lot of game objects. All right, now I'm going to go ahead, I'm going to click on the rotation thing. And with rotation, I'm going to double click on the camera, which will zoom in a little bit on it. You can grab these different lines here to give yourself a different rotation. So I want to kind of give myself a view from above. So that's kind of looking down. Now I'll move the camera up like that a little bit. Go back to rotation. Decent. It's looking pretty much straight down on it, or kind of at maybe a, I don't know, 75-degree angle or something like that. All right, so this is just like you're taking a scene in a movie. We've put the camera somewhere, and this is the angle the camera's looking at. All right, you can mess with it until it looks the way you want. What's neat, so actually it's more difficult to do this like this than it will be when we bring it into virtual reality. Because with virtual reality, we're the camera. So we take the main camera out of here, and we actually put this thing in there, a couple different versions of it, but we can put this camera rig in there that has the VR handsets and stuff all with it, and that's your camera. Your camera is wherever the helmet is. You turn, camera points there. You turn this way, camera points there. It's all built in. You don't have to worry. You know, if you want to look up, you just look up, and you're seeing stuff. Okay, so we got our camera kind of set doing something here. And of course, all that was done when the game was running. So none of that stuff actually took, because I actually had the game running. So let me move that again real quick. Actually, oh, it was. I was testing it. So everything was fine. Okay, so now we're going to go ahead and we're going to make our sphere. So, one thing you're going to kind of have to get used to, and this will be through practice, and I haven't done it too much with the trackpad, so I'll look at my own practice here, I guess. Ooh, what did I just do there? Oh. I'm not sure any of those gestures are consistent. So you can mess around with zooming in, zooming out. This is kind of using the scroll wheel. But if you want to center in an object, let's say I want to mess around with the sphere, you can double click on it. It'll zoom that in and bring it right in the center of the screen. Okay, so I'm going to mess with the sphere here. Now I'm going to go ahead and I'm going to make this sphere a rigid body. So I'm going to add a component. You can go and find it inside of physics and rigid body, or you can just search for RIG rigid body. Okay, and then I'm going to go ahead and by default a rigid body has gravity. So that means the sphere should fall out of the sky. So I'll go ahead and hit play. And there's my sphere. It fell, but notice it stopped. It landed on the plane. Well, why did that work that way? Let's go and look at our plane. Here's our floor. Our floor has a mesh collider attached to it. Now, mesh colliders only work with default rigid bodies. Okay? Our sphere itself had a sphere collider. We remember before our cube had a box collider. Colliders are like, a sphere collider, well, let's assume a box collider for this example. So I have a big box that's around me as I'm walking around. And as I'm bumping into stuff, I don't want to see, in a game, you don't want to see your arm pass halfway through the table before you react, right? So basically there's a box surrounding me, and when that box collides with this rigid body, I can then respond to that. I can either have the physics engine do it by default, which is what we're seeing right now, or I can decide to make it a trigger. So to show you that, here's the sphere collider that's on the sphere. I'm going to go ahead and say this guy's now a trigger. I'll hit play on this, and we're going to see he's going to fall right through the floor. All right? Because by me making it a trigger, what I said, I will now be in control of what happens when this collider hits something else. Okay? And let me show you that. I'm going to go back into my code here. In theory, I'm going to get rid of fixed update for right now. And I'm going to insert this function called Ontriggerenter. So whenever we want to programmatically handle things bumping into other things, we use this function called Ontriggerenter, Ontriggerexit. So Ontriggerenter would be if I'm walking near the table and my box collider enters this other collidable thing. Okay? This function will get called if I set that guy up as a trigger. So this function would get called. And then I can decide what I'm going to do. So right now I'm going to say sphere collided. Something like that. All right, so that's Ontriggerenter. And this is another one of the reasons why Visual Studio is better than Mono, is Visual Studio will do auto-completion on these functions, where Mono will not. So you would have to go and look up the function, copy it, paste it in here, or just remember what it takes. It's not that difficult of a function. Okay? So what this says in this script is whatever the game object that this guy is attached to, if he has a collider that is a trigger, when that trigger fires, this function will get called. And it will get called for all scripts that are attached to this guy. So I'll show you that in a second, because I could have two different scripts attached to the sphere, and both of them would have their Ontriggerenter called if I want to respond to the trigger two different ways. So I'll go back here. So now I've made my sphere collider a trigger, which effectively says, don't make this guy act based on normal physics rules. Let me handle what happens when it collides. Make sense? So now we'll go ahead and play. We'll see it fall through the earth again. We'll go out to our console. Oh, remember before when I told you that the mesh collider only works for normal rigid bodies? So we have to make this mesh collider won't work for this guy. So I'm going to actually turn that off for a second just to show you this example. I'm going to put a box collider on my floor. So I just unchecked the mesh collider, so that disables it, and then I added a box collider. Box colliders will work normally. Okay, so I'll go ahead and run this again. That guy fell through. It still didn't call. But why? That movement script was on our cube. So I did save it, I just never actually added it to the cube. Now my movement script's on the cube. All right, fell through, and there's our sphere collided thing. And let me back up real quick and make sure that it does not work with a mesh collider, because mesh colliders I don't think would work with triggers. Let's find out. Oh, it did. So we could just do it with a mesh collider. So it's really the other way around. We can't make our plane collide with other things when it's just a mesh collider, because it only works for non-rigid bodies. But anything that is a rigid body can collide with that mesh collider. So it's a one-way street when the thing is a mesh collider. All right, so now since we know that this guy is colliding, we can programmatically decide to do something about it. So I'm saying sphere is collided. Now, one thing I can do here, though, is let's say that I want to do something in response to a collision, but I also want to have it act normally under physics. That might be something I want to do, right? So something I can do in here is when I say this, this is the dude that this is the game object that this script is attached to. So if I say this dot get component, and I'm going to get the component of type, actually this guy's a sphere collider, right? Is that not how you do the...
I don't think you're supposed to put it in.
It's in there, right? Yeah. Oh. I get what I'm doing, stupid. So this is going to be the sphere collider, like this. Dot is trigger is false. So I'm asking the guy who owns the script, I want him to get one of his components. Out here, we've advertised that here's the list of components associated with the game object I have selected, right? Right here at the bottom, we have a little button that says add component. So since this guy is the guy that has the movement script associated with it, when I say this in here, I'm talking about that sphere game object. I'm saying sphere, give me one of your components. Specifically, give me your sphere collider. Now, objects can only have one active collider. So when I say give me a sphere collider, there will only be one. Okay, so I want your sphere collider. Once I have your sphere collider, I'm going to grab its attribute called isTrigger. I'm going to set it to false. Notice that before, it was true. So it started off as being a trigger. So then when it hits the collider, when it hits the floor here, what happens? It calls this function. Because I want to do something in response to it. I want to programmatically do something in response to it. But I also want it to act like normal physics. So now what I'll do is I'll say, okay, first things first, you're no longer a trigger. Now you act like physics. You do physics stuff. And now I'll move on and do some other stuff. Okay? Now the interesting thing is, since we used a plane, whether it'll catch it before it's already fallen through. I think it will. Yeah. So it stopped, it hit, it acted like physics, but I still was able to determine that the sphere collided. I got that information. That make sense? All right. So those might be things that you want to mess with. So what we're going to do is we're going to start doing some stuff from this tutorial. So I have this movement thing. So what I'm going to do is I'm going to go ahead and steal this code, and I'll tell you what it's doing as we go through there. Actually, let's just... All right, so what they did is they have notice we already had a public variable speed, as we're using it down here. So that allows us to, through the Unity editor, set the speed for something, right? Okay. Now we're creating a private variable of type rigid body, because we might want to work with the rigid body component that's associated with the game object that this script is attached to. So what I'm going to do right here inside of start is I'm going to say this.rb is equal to this dot get component, I want the rigid body component of this script. So I'll go ahead and set the value of that variable equal to the rigid body associated with this script. Now, associated with a game object that owns this script. Now, keep in mind that there better be a rigid body. Let's go back out here and check. In Unity, here's my sphere. We do have a rigid body. So we're good. There is a rigid body component for us to get. If there wasn't, we would be grabbing at straws. Right? We would say, hey, sphere, give me the rigid body. And he's going to say, I don't have a rigid body. Here's a null value. And then you'll get error messages. All right. So if I want to programmatically get this component from my sphere inside the script, I give myself a variable for that type of thing, the rigid body. And then inside of start, I can go ahead and grab that rigid body right here and set it equal to that variable. Make sense what I'm doing there? Okay, then down here in fixed update, which actually is interesting. I wonder why they're doing it in fixed update rather than update. But whatever. Maybe it's because the keyboard input acts on a continuous basis, because you definitely wouldn't want to do inputs on fixed update with VR. Reason being is you might try to detect like when a trigger was pulled, and if you pulled it in between those third of a second time periods, it wouldn't detect it. You want to get it on a per frame basis. But we'll go with the code they have here. So what we're doing is we're going to drive this sphere with the keyboard. Okay? So we're using the get axis. So we have the horizontal and the vertical axis. That's going to be our arrow keys. Okay? So there's a class that exists in Unity called input. We're asking it to get us one of the two default axes, horizontal and vertical, and we're putting those inside of some variables. That gives us the current value of those axes, where this game object currently lives. Then we're going to go ahead and we're going to create a vector3, which, like I mentioned before, is a fancy way of saying an XYZ coordinate. Okay? They just make it, by calling it a vector3, it sounds scarier, I think. So we're going to create a vector3, and it's going to be a brand new vector3, and it's going to be wherever we currently are horizontally, wherever we currently are vertically, but notice that this vertical is on the Z, not on the Y. So Y goes up and down, X goes side to side, Z goes the other side to side. Make sense? So Z is depth. So we're saying we want to create a new vector3 flat on the surface. I don't want it up in the air. Okay, we're not going to be able to take off flying with this guy. But I want the position of the XYZ position of this to be wherever I currently am horizontally and wherever I currently am vertically in terms of those two axes. And then we're going to take our rigid body and we're going to add some force to it. The force we're going to add to it is the movement that the direction we're currently trying to go, times whatever speed we put in. So that'll be extra force. If I just put in the movement, it'll do it on a force of 1. So it'll move it just a little bit every 3 times a second or something like that. By giving it a speed, I'm giving it a multiplier of how fast I want it to go. So I'm going in that direction, but I'm really going to go in that direction with a speed associated with it. Okay? Let's go back in here. Let's go ahead and set the speed to maybe 10. We'll go ahead and run this guy. He dropped, let's turn his trigger off because I deleted that other code. He will operate in normal physics now. Okay, so he'll fall and hit. So now I'm driving the, well, we might as well just do it. There we go. Probably need some walls. Okay, so we saw we can make our guy move around with the arrows by adding a force to it based on the current direction of the horizontal and vertical axis multiplied by our speed. Now, something we can do here, I'm going to restart it so I get my guy back here, is I'm going to start moving it, and let's say we decide that that's a little bit too fast. I'm going to get it stopped so it won't just roll away. Now I'm going to change it to a speed of 5. All right, so that's a speed of 5. A little bit more controllable. See, the funny thing is right now my I don't think my plane is completely flat. No, it is. My plane is flat. I wonder why my... Huh? The drag? Yeah, I wonder why it hasn't just stopped. Probably because we're not doing it based on time. It's good enough. Let's say we think it's too slow now, so I'll change it to 50. Gone. Zipped out. So that's kind of the idea where we can test it in real time. If I stop this, it'll bounce it back to what I had it at, which was 10. Okay, so we want to go ahead and we want to build some walls on this guy. Let's make sure that's kind of the next thing the tutorial wanted us to do. So we just did the moving player stuff. We've already kind of messed around with camera stuff, but now this is kind of an interesting thing. What if we want the camera to follow the player? So right now we just have this like bird's eye view, right, where the camera's looking down on the scene. So if we want to move the camera, we can create another script. They call this guy camera controller. I'll steal this code from it. So I'll go back to my project. I'm going to create a script here, C# script. Call this guy camera controller. I'll go ahead and open it up. That is range. Okay. Now, notice that this guy has a public game object called player. Now, for anybody who's just learning Unity for the first time today, what does it mean when I make a variable public? What's the side effect of me making a variable public? Pops up with a thing in the corner? Yeah, it exposes the Unity. So if I go and hook this up to the camera, I would then have a little spot to drop the player. So let's just go do that real quick, then we'll come back to this code. So I'll go to my camera. So I selected the camera there. And I'm going to drag that camera controller over here onto that guy. And notice it has a little spot here that's waiting for me to give it another game object, my player. So my player is my sphere. So I'm going to drag my sphere in there. So I've connected another game object to this game object script through drag and drop. Make sense? And that works all because I made this game object a public variable. So at runtime, this guy will now be equal to my sphere. All right, so then they have another private variable. That's a vector3. What's a vector3? X, Y, Z coordinate, just a position, right? So this guy's a private variable, so that's just for use in this script. Not going to be exposed to Unity. So on start, this guy gets called one time. I'm going to go ahead and set offset equal to the current position of this guy. So I like to use the keyword this, even though most people don't. I like to say this dot transform dot position. I'll just say this dot offset. And I like to say this dot player. It's more of just a me thing than anything else, but I also like it because it does command completion and you don't have to worry about misspelling stuff. So what I'm saying is I want to set my vector3 offset, this guy up here, equal to, this guy is the camera. Okay, so the game object that this script is attached to is our camera. So I want to take the camera, that's what this is. I want to take his transform. Okay, and a transform is an XYZ position as well as a rotation. Come pop back out here. There's my camera. Here's a XYZ position. Here's a rotation. And then there's also a scale. How big it is. Okay, so there's 3 elements to a transform. The one we're getting here is the position of the camera. Okay, so I want to set my offset equal to the current position minus the player's position. Okay, that's going to give me the distance between the camera and the player. So we'll probably end up having to manipulate the camera down so it's kind of sitting, riding behind the player's shoulder type thing, if spheres have shoulders. But in any case, the offset is the difference between the position of the camera and the position of the player. Now, one thing I'll throw it out right now and mention it is there is a second kind of position. It's called local position, as opposed to regular position. Now, we should be using regular position here, but I'll explain at a high level real quick what local position is. Earlier, I mentioned that we have this thing where you can nest game objects inside of each other. So you're going to have a game object with another game object in there. Local position is if I have a game object inside of another game object, its local position is its position relative to the position of its parent, not its position relative to the whole game world. So this guy right here, in terms of the game world, might be at position 300 to 55, something like that, some off in the middle of nowhere. But relative to its parent, it might be 0, 1, 0. So its local position would be 0, 1, 0. That would be the vector 3. Because that's its offset from its parent, would be local position. Okay? But that's only if you have game objects that are inside of other game objects. In this case, at this point, we're dealing with everything in just world space. So our sphere, our camera, these are 2 completely separate objects that just happen to be living in the same world. Okay? So that's why we're getting the position of the camera in the world and the position of the player in the world. You know, what's interesting is I actually think local position would work here because I think in this case, local position and position will be the same. I'm not positive this is the case, but my belief is that both the camera and the player are children of the scene, of the world. Therefore, their local position relative to the world would be their position relative to the world. Those would be the same value since their parent is the top level. But the correct thing to use here is position. That's always the global position in world space. All right? So this is going to give us the relative offset between the current position of the camera and the player. That means we probably need to set the camera up to be, kind of sit at a position, a certain place. Now, late update. So that guy is low priority per frame basis. So we still want it to happen often. We want the camera to pretty much follow our player. But, if we miss a frame, it's not the end of the world. Okay? So what we're going to do is we're going to set this dot transform dot position. And who is this in this case? It's the camera. Okay, so we want to set the camera's position equal to wherever the player's current position is plus that offset. So we can initially position the camera where we want it to ride behind the player. And then when we start the game, this script inside the start function will grab that distance. That's the offset. It'll grab that once. So we're basically saying, here is the position I want the camera to be in. Then in late update, I want it to maintain that position. Because I've already calculated that offset. Now go ahead and give me, on late update, if the player's moved, make the camera move with them. Make sense? So we're grabbing that offset once, and then we're maintaining that offset as the player moves. All right, so that's on the camera controller. So this is now we have two different update type things happening. The sphere is getting updates for user controls, right? And they happen to have it inside of fixed update, so it's on time, which I think is because it's on the axes, and those axes kind of accumulate a value. That would not be what you'd want for button presses and things like that, because you'd want those to be real time. And you might press a button faster than 3 times a second or something, or whatever the actual thing is. It seemed like it was faster than 3 times a second, but it's not 80 times a second. It was pretty clear it wasn't that. So I'll come back out here, and let's go ahead and I'm going to go ahead and let's get our camera kind of positioned right behind the player. So I'll move it down some. Yeah, the rotation is kind of off. So because I was messing with rotation before, I'm going to come over here and I'm going to reset rotation. So that zeroes out the rotation on my camera. So now when I go to do rotation, I'm kind of starting from scratch. All right, that's the wrong one. Is this the right one? Oh, it's the same one. All right, so the issue here is we're looking at the scene from one angle. This guy up here in the upper right is going to be our friend. This gives us a different perspective, and what's often helpful is if we click on Y, the Y-axis will look straight down in our scene. And what we're going to see here is that our camera isn't exactly where we think it is, based on the view we're looking at right now. So I can click on that. So here's the camera, and it's actually pointed over to the side. So I need to rotate it here to bring that stuff into view. Now I can move it up towards the player. I can then also lift it up in the air a little bit. Go back to the rotation, and now I should be able to, yeah. So that, okay, so we want the Z to be 0. Okay. We want the Y to be 0. And maybe X to be 30, something like that. And then we will kind of center it behind the, so our sphere is at 0, 3.95, so we'll make that a 4. And then we'll take the camera and we'll put this guy at 0, 4.75, that's why it's elevated a little bit. And then we'll put it at 0 on the, oh, we had it kind of back. So -1 on the Z, maybe 1.5. See what that looks like. We actually might want to also maybe lift that up to 5, trial and error. All right, so that's going to be our starting point. So we kind of have the camera, if this is the sphere, we have the camera up and back and then angled down on it a little bit. You can make yours look however you want, but the idea is that since we have the camera script on the camera and we have the movement script on the player, when the camera script first starts, it's going to grab the offset, the current offset that we just set up. That way we're going to maintain that distance between the camera and the player. And we're never messing with rotation. So right now our current rotation is what it's going to stay at. So these guys are just going to follow each other. Well, really it's the camera that constantly resets its position to be relative to the player by that offset. We'll go ahead and hit play. Sitting behind the player, camera's kind of going with it. That's in late update. Whoa, whoa. We are experiencing the sphere's death. You know what they should do in Unity? It would be kind of, I think, funny in these kind of situations is because right now we're falling into the nether. I mean, look at the Y. It's negative. It's just literally continuing to fall. We're at negative 2,000, 2,500, so on and so forth. At some point, they should have a bottom that has like spikes and stuff. You know, like if you're sitting there, you're debugging, you know, you forgot to hit play, you come back, and there's just like this wreck scene. Something horrible has happened. Okay, so we'll say that looks pretty decent. Looks okay. We got our you know, guy following. Maybe our world's a little bit small here, but you know, that's okay. All right, so let's go ahead and let's take a quick break. Can we make it 6 minutes? That way we can get the last hour and get the last stuff done. So let's take a 6-minute break and come back, and I'll try not to get off topic. And we'll go.